Um, correlation is not causation. So correlation of two effects may be the result of a third factor, which causes them both. And this is a rather good example. This picture here, it shows a graph which shows the number of storks' nests on the roof of a building, and they're correlating that with the number of children. And the implication is that the number of storks' roofs or nests on the roofs are causing the number of children. This is not true, but but the picture shows another way in which one could look at this. It shows that there are larger houses for the people who have more storks' nests. Now, the larger houses are also not causing those children. In fact, it is having those children that is causing the larger houses. But even that correlation doesn't always occur in any given instance. It may be that because the family doesn't have the resources to build a larger house, they may simply pack the people into the house more tightly. So that all of those correlations may fall depending on how the problem of more children is solved within the family. And there is another cause altogether of there being more children. So finding the cause of there being more children is a process of winnowing away all the beliefs and finding uh, finding whatever it is that is the cause within the individuals and families involved that is actually leading to there being more or fewer children. But we see this kind of problematic analysis all the time, particularly recently when we've discovered after uh, fertility rates have been declining for decades, we've discovered that, oh my God, it's a problem. And of course, the answer to that is it may or may not be a problem in all ways. It's a problem in certain ways and a solution of other situations. So the idea that low fertility is in some objective sense a problem is also a belief, which may or may not be valid or validated by any given particular situation. And can be uh, it can be resolved or at least alleviated or mitigated by various solutions, most of which require uh, working outside of the belief system that got us into the problem in the first place. And in most cases, uh, politicians and even researchers either find it difficult or don't want to get outside of the belief system that caused the problem in the first place. Benefits of statistics. Statistics is tremendously useful, but there's an old adage which was famously repeated by Mark Twain in the middle of the 19th century. Uh, when he was talking about misleading statements, he said there are lies, damned lies, and statistics. What Mr. Twain was pointing out was the extent to which statistics are frequently used to uh, to prove confirmation bias or cognitive bias, or to mislead people to believe the thing that one wants them to believe. So statistics is tremendously important as a uh, method of analysis within the scientific community, but it is also, given how important it is, it's frequently misused by people who want to have people come to a conclusion that is more in accordance with their own desires. So one has to be very careful about how statistics is used, even though one should recognize that statistics is tremendously important to help us overcome the problems associated with cognitive bias. So there's regression to the mean, which is one particular issue associated with statistics. It means that variables that are much higher or much lower than average on the first measurement are likely statistically to move towards the statistical mean as one continues in time. This occurs famously with stock prices or stock funds uh, that are high in the previous 5 years. And very often, those who are trying to sell those stocks to people who don't understand statistics uh, point out that their 5 year record is above the stock market uh, average. And so they're showing this as being something that indicates that a person should buy their fund. And the reality is that in most cases, the vast majority of cases, those funds are inevitably going to be reverting to the mean. There are a few exceptions, but those are very few. Similarly, there's a famous idea that there is a curse of people whose covers are on, or whose faces are on the cover of magazines, uh, most famously Sports Illustrated, so that's sports people. Uh, but the reality again is that people who are on the cover of a magazine that illustrates their career are most likely to be at the highest point in their career. And their career is likely to dip afterwards because it's very difficult to sustain that career for a long time. There are clearly counterexamples, but those are few. Law of large numbers. The larger the data set, the more valid is the data. And this applies most particularly in the cases when the data is valid. So one has to be very careful that the data itself is valid. Uh, and if that's the case, then larger data sets are certainly more likely to be valid than small ones. This is simply a statistical uh, result. So there's sigma, which is the indication of the probability of an outcome. 2 sigma corresponds to a 95% confidence. Uh, 3 sigma refers to about 99.7% confidence in the result of a given uh, of a given statistical set. 5 sigma is normally the standard in physics, and that would be 1 in 3.5 million% chance of an incorrect result. So that's very highly uh, valid, but one has to be sure that the evidence on which the result is based is valid. Otherwise, it invalidates the entire conclusion. So in sum, for the whole series, one wants to avoid not thinking like a scientist. And this is a quote from Adam Grant in Think Again, a 2021 book. Scientists morph into preachers when they present their pet theories as gospel and treat thoughtful critiques as sacrilege. They veer into politician terrain when they allow their views to be swayed by popularity rather than accuracy. They enter prosecutor mode when they are hell-bent on debunking and discrediting rather than discovering. So don't do that. Thank you very much, and I hope this has been useful.